All right, here's our video for 5.2a, solving absolute value equations. So in this section right here, we're just going to do a quick review of what we talked about in the previous lesson, and that is that the absolute value is the distance from zero. So the distance of a value from zero. It is always positive. So if I saw something like this is telling me to find the absolute value of 3. So how many places from 0 is 3? And the answer is just 3. Notice the bars are gone and we have just a positive number. If I had the absolute value of a negative number, the question is how far is it from 0, the physical distance or measurement, and that answer is positive 17 spaces from 0. So the bars are gone and it's a positive number. So when we're talking about absolute value equations, here's the most simple form we could be talking about. Solve the absolute value of x equals 7. So when we're solving for the variable, we want to find any and all solutions that would make that equation true. So the question in this simple version that we want to ask ourselves is this. What two values for x will give an absolute value of 7? So what two numbers can I plug in for x that after I take the absolute value, it will equal 7? And so you probably already thought of it. It's 7 and negative 7. And so I want to use this as a pattern for setting up these other equations that are more complicated. So here's the pattern I want you to see. If you have an absolute value equation set up like this, what you're going to do is take the stuff inside, which in this case is only x, and you're going to say that that stuff inside can either equal a positive 7 or that stuff inside can equal negative 7. And in this case, there's no more solving to do, so this would be our answers. So keep this section in mind while we do these other equations. And these equations are set up, they're sort of, each one is leveling up from the one before. So here's the one we just did, absolute value of x equals 7. And then here's the one we're going to do next. You'll notice the only difference is, one, the 7 is now a 10. But inside, I'm multiplying x by something. So that's one way that this is leveled up. So the steps are to isolate the absolute value. So that means get it by itself, nothing in front, nothing on the right, nothing being divided in the bottom. So nothing on the outside. So we already have it, so we don't actually have to do step 1. Step 2, write the equivalent equations. What do I mean by that? This, what we did here. We had this one equation, and then we wrote these two equivalent equations. What did we do? We took the stuff inside, set it equal to the positive version of this number and the negative version of that number. So what that will look like here is this. Take the stuff inside and set it equal to the positive version of this constant and the negative version. Okay, because that stuff inside can either equal 10 or it can equal a negative 10. So it can either equal 10 or equal negative 10. We write it down literally as equations. And then we solve those two equations. So x can be 2 or x can be negative 2. Okay. So now we are going to go up here to example 2. Here's how this equation is changed. So instead of 5x, I have 3x. But now I have something being added or subtracted inside of there. But we're still in, so the first step is to isolate, but it already is. What I mean by isolate is this is my absolute value. There's nothing being multiplied in front. There's nothing being added or subtracted on the end. And there's nothing being divided on the bottom outside. So the absolute value piece is isolated. So then I go straight to step 2, write the equivalent equations. So take what's inside, 3x minus 5, set up 2 equations with it. One equation is going to be equal to positive 7, and one equation is going to be equal to negative 7. Notice I didn't change the sign of anything inside the absolute value. The only thing that's getting a sign change is the constant that's on the right. So don't change the sign of anything inside. Just change the sign of the constant on the right. And so then we have these 2 equations to solve. So you are going to add 5 to both sides, and then divide by 3. And that first equation gives me x equals 4. And then on the second equation, I add 5 to both sides, 3x equals negative 2, then divide by 3, x equals negative 2/3. And I'm going to put or in between here because it can be one or the other will make the equation true. On example 3, this is our first time where we have to do step 1, isolate the absolute value expression. So this piece right here is my absolute value. Isolating it means getting it all by itself on one side, but right now on the outside is a minus 5. So I need to move that 5 over by doing the opposite to both sides. And now the absolute value is isolated. So now I go to step 2, write the equivalent equations. So you take the stuff inside. You're not changing any of that stuff inside. Just 4x minus 3, 4x minus 3. And that can either equal a positive 7 or it can equal a negative 7. So I want you to pause your video and solve these 2 equations. You're going to be adding 3 and then dividing by 4. So you take a minute, pause, and work that out before you come back. So for the first equation, I have 4x equals 10. I divide it by 4, and then I can simplify this fraction by dividing both of them by 2. So x equals 5 halves from the first equation. And then the second equation, I add 3, divide by 4, and x equals negative 1. And then on this last example, there are 2 things outside of the absolute value. So here's my absolute value. My first step is to isolate it. So that means getting it all by itself. But right now there's times 3 on the front and minus 4 on the right. So in case you're stuck and you don't know which one to take care of, think about it like this. Let's say instead of the absolute value, let's say I had this. Okay, all I've done is replace the absolute value with just a regular variable. What would you do first? You would add 5, and then you would divide by 3. That's the same thing we're going to do here. We're going to add 5, and then we're going to divide by 3. Let me tell you what you're not going to do here. Do not distribute into absolute value. Okay, do not do that. It works sometimes, but not all the time, so just avoid it completely. So instead of distributing this 3, we're just going to divide it off. So now I have x plus 2 equals 3. So now I have isolated the absolute value. Now I go to step 2, write the equivalent equations. So you take the stuff inside, don't change the sign on the stuff inside. You just write it down, x plus 2, x plus 2. That stuff inside can either equal a positive 3 or it can equal negative 3. And now you just solve those equations. You subtract 2 from both sides, and that's going to give me x equals 1 or x equals negative 5.